Hello everyone. Today we are going to discuss about IoT consensus mechanism analysis. The consensus mechanism is the thing which makes the n number of devices to work in the same network and agree the conditions and terms of the network and transmit the data in between the systems. IoT networks are made up of a large number of devices that need to work together to accomplish various tasks. In order for these devices to work efficiently and effectively, they need to be able to agree on a common set of rules for communication and decision making. This is where the consensus mechanism comes in. Consensus mechanisms are algorithms that allows devices in the IoT network to come to share agreement about the state of network. They do this by ensuring that all devices in the network have the same information and that they all agree on the next step to take. There are several type of consensus mechanism that can be used in IoT network. These are the list of five: proof of work, proof of stake, delegated proof of stake, practical Byzantine fault tolerance, and federated Byzantine agreement. We will discuss everything briefly. First, proof of work. In this mechanism, devices in the network complete to solve mathematical puzzles. The first device to solve the puzzle is rewarded with the right and add the next block of data to the blockchain. Proof of work is energy intensive and requires a lot of computational power, which makes it less suitable for IoT devices. And next is proof of stake. In this mechanism, devices in the network are selected to add the next block of data based on the amount of cryptocurrency they hold. This means the devices which more cryptocurrency have a higher chance to being selected. Proof of stake is more energy effective than proof of work, but it can be more centralized and less secure. Next one is delegated proof of stake. This is in this mechanism, devices in the network vote on the set of witnesses who is responsible for adding a new block to the blockchain. These witnesses are selected based on the number of votes they receive. Delegated proof of stake is more efficient than proof of stake and more decentralized than proof of stake. Practical Byzantine fault tolerance. In this mechanism, devices in the network are selected to act as a validators. Each validators receive a copy of transactions data and they must come to a consensus on the correct order of the transaction. Practical Byzantine fault tolerance is fast and effective but requires a high degree of trust between devices. And next is federated Byzantine agreement. In this mechanism, devices in the network are grouped to the federations. Each federation has its own set of validations who comes to consensus on the state of network. The results of each federation or the combinations of forms a global consensus. And now we are going to see the complete flow and the complete architecture of our visualization, how it works. Initially, these, if you see here, there were sensors which will access the data like temperatures, wind, and speed. And these sensors are connected to the Raspberry Pi module. And these Raspberry Pi modules are placed in the satellites. And with these Raspberry Pi modules, a two or more number of satellites are communicated and transmit these sensor data based on the consensus mechanism. Means the data transmitted based on some agreement and some rules applied on it, and that data, like from specific sender to specific receiver, what data has been transmitted will be shared through us by making an post call, API post call. And while doing that post call, then the data will be stored into our MongoDB. And for analyzing purpose, we are accessing the data and we are visualizing the data and building a dashboard by applying of some visualization algorithms on it. And then if you see the data flow, if you see here, there was a Raspberry Pi module. From the Raspberry Pi module, the post call applies and the data will be sent to the MongoDB. And from there, by the get call, the data will be come and we are applying some visualizations on the data, and then we are displaying the dashboard. and this is what the data format which we are getting. And we are getting two types of data. One is node data and one is message data. The node data specifies about the id, port, address, pairs, honest, and message data specifies about the sender, receiver, and date. And what is a we are getting payloads. In the payloads we will get the readings of sensor data like temperature, wind, speed. And if you see here, the id specifies the sender or a receiver, and the address specifies the IP address of the particular ID, and port specifies which for which port does the IP is connected, and the pair specifies that which are all the list of IP addresses does the ID is connected, and honest specifies that whether we can believe the data or we cannot believe the data. The true specifies we can believe, false specifies we should not believe. And here the another thing is message data. In this message data we are getting sender, receiver, date, payload. In the payload the sensor data is coming like temperature, wind, speed, and I will explain briefly about everything. This specifies this payload data was transmitted from this sender to this receiver on the date of 5th 12 2022, and the temperature specifies the temperature in Celsius, and wind specifies the wind direction. It means north means one north. Every direction has a specific number. There are totally 12 or 16 directions. The wind specifies a direction, and speed specifies the wind in this particular wind speed on this particular direction. And this is the dashboard which we are creating by analyzing the data, the both node data and message data, and adding some visualization techniques on the data. And we go briefly into it. And this is the node data which consists of id, port, address, and pairs and honest. Id specifies the sender or a receiver, and the address specifies the IP address of a particular sender or receiver, and port specifies the in which port does it is connected to the other IPs, and the pairs are the remaining IPs which are connected to that particular sender or receiver's IP. And the honest specifies whether we can believe the data or we cannot believe the data, or else we can believe the particular sender or receiver or we cannot believe the particular sender or receiver. And we can go thoroughly through the analyze what I have done. And now if you see, I have made a drop down based on the honest data. There are two values, one is true and false. Based on selection of values we can get list of data which has the honest as true. And if you see here, these are the data which is having the honest values as true, and there are totally 57 pages like this. And if you remove the true and if you make it as false, there are less people which are not honest. It is good, it is good that there are so much of people which is are having which are honest, and there are less which are not honest. But we should also find which are all the IPs which are mostly unhonest, and which are all the IPs which are mostly honest. And then we can go thoroughly through the analysis. And if you see here, these are the this is scattered graph consists of which address is IP address is connected to which port, and what are all the connected pairs through it. And if you see here specific, this is 193.97.79.210. This is having, I think so here, don't know, it is not getting here. Mm. Okay, suppose let's take a random IP. Okay, here if you take this is the list of pairs which are connected to this particular IP, and that is the port 24,455 244,59, and the IP address is 228.53.6.40. We can go through like which IP address is which connected to which port and which are the pairs connected through it. By we can analyze by using this graph. And then we are doing a percentage honest value. There are 10.2% unhonest messages we are receiving, or else 10.2% unhonestable people are there in our total data. and the remaining 83%, 89.8% are honest, and this is good. Only 10%, but we should not that the 10% also make some changes in our data, because our data should be honest, right? We should not be honest, because if the data was honest only, we can believe then another satellite or another um people. Okay, let's go through briefly into analysis. And if you see here, we have made a graph on the address port and honest. Here if you see there, these IPs are having mostly unhonest messages sending. The above IPs are sending mostly unhonest messages, and those IPs are IP address are 82.90 and 140 to 50. There are so many. These red color marking are unhonest. If you want to see it more clarity, just click on this blue thing, and the blue eye true IPs will leave, and we can see the only the dishonest IPs which are all sending messages. And if you want to see only true IPs which are all sending messages, we can see like this. We can see which are all the IPs which are sending true. And here also, if you want to get only how many messages, 449 messages are honest, and if you want to get only dishonest, you can go there, and if you select the 51 dishonest users are there, like this. If you want here also, if you want to deselect, if you triple click on it, I think it should go. Okay, like this you have to select for every particular IP, and we have to do analysis on it. Okay, now if you go oh, I'm more downward. Okay, it's good. And I have scattered a line graph on a IP and a port, and I'm thinking of knowing which port is connected to which IP address, and what are all the connected IPs out there for particular ports, and what which port is mostly using by these IPs, and which port is least using by these IP addresses. Like if you see here, this is 39,000 port is using most by these IP addresses. Most of these IPs are using the that ports only. And if you see the messages here, if as if you see, this is the sender and this is the receiver, and on this particular day, this was the data which has been transmitted, and if we can see the whole data like this, the complete data. There are so much of messages are there. And then I have plotted a graph on what is the temperature that has been sending by senders, and I have seen that mostly there was 30, and leastly there was 20. The temperature was in between of 20 and 30. The mostly it's a good, but if it was more than 35, 40, it was not good. But it was trending 30, it's a good temperature only. Not it was not a bad temperature. And if you go below deeply, I have split it on day wise, on which day what is the temperature, and what is the wind direction, and what is the speed of the wind. And if you see here, first first month first, if you see here, the temperature was 24, and then the one second, we can see it clarity. One second, if you see, no, if you have to think here, I think so. One second, one second. We can extract this, yeah, like this. Yeah, now we got it. Now if you see here, temperature on first is 25, and the wind is 16, and the wind speed is 115. As I mentioned, there are 16 wind directions, and the on the 16th wind direction, the wind speed is 140. Like this, we can see on which particular day what is the data transmitted, and by this we can know on the particular satellite on which area, and we can know on the particular area, this was the temperature and this was speed. It is transmit analyzing the data and transmitting, and in backend we can also analyze the atmosphere data also. It is helpful in both ways. And if you see, this is the wind and speed graphs comparison. When the wind direction was in 12 and the speed was, oh, 1 second, that is, speed was 189. In 12th wind direction it was speed 189. And we should compare on, based on this is the previous 70 is the value which we can identify by going there and finding where is 70, and we can get the value. The suffix is the value and previous is the IDs we to find the values. And here I have kept a slider. This slider helps us to find, based on this slider is based on the temperature data, and the temperature was, as we discussed previously, it was from 20 to 30. And I have applied a line graph on the wind and speed. So on the, if the temperature was greater than 28 29, what is the wind direction and what is the wind speed? I thought of doing this analysis on this speed, on the rising of temperature. What is the ratio of wind direction, wind speed? So I implemented that graph, and this is on the variation of temperature. What is the ratio of all three? If the temperature is 30, what is the wind speed is 171 and wind direction is 9. On the ninth wind direction, the temperature was 129, right? Yeah, it's 171. It was very high. It was very high, right? Yeah. And then we can know on particular day what are all the list of messages were sent. If you selected on 11th first, these are all the messages sent from particular sender to particular receiver. And this is the data of the particular messages which has been sent on that day. And as we discussed before, the IDs are just a sender or a receiver. So I have grouped the data on IDs, and we have combined the total data and for a good visualization. And if you see here, I have implemented on a sender, for a particular sender, what is the honest. We can find, we can find easily which sender is giving honest results and which sender is giving dishonest results, or dishonest messages were sent by this particular user. And if you see here, I have grouped by on the sender and temperature and honest values. And if you see here, this last 7 to 8 are giving more dishonest messages. These are all the dishonest people who are giving, sending and dishonest messages. And we have to note these senders and view for another analysis, because the final motto for this analysis is we have to find dishonest messages sent by how many people and how frequently they are sending. If you see here, we can see how frequently they are sending. The particular sender has been sent twice dishonest message, and this particular sender has been sent thrice, and he sent 4 times. These people are sending, keep on sending dishonest messages. There is no use of this data, right? You have to find who are the senders which sending the dishonest messages. And if you see on a particular day, who are all sent the dishonest messages on the particular day first, the this particular IP has sent the dishonest messages. So based on this, we can find who are all the dishonest data transmitters by this analysis. And if you see here, on a particular day, which IP is connected to which port, we can see here, because the port may be changed, like the particular IP may change these ports and transmit the data, right? It may varies on the port also. We have to analyze on it, on which port this data has been came, and based on that, which the data, dishonest data is coming. And here is the thing, we have to we have set the honest value true, and on a particular date we can see what are all the messages has been sent. on a particular date honest messages has been sent. If you want to select dishonest, if there was a dishonest message and sent on the day, there will be no dishonest message sent on first. And let's check, is the, by god grace we can get anything. No dishonest. It's good, man, it's good. If it is not dishonest, it's good. Yeah, on 25th one dishonest message has been sent, but finally we got some dishonest messages. Okay, and I have checked like a particular sender how many messages that he sent. There are the highest is five. The particular sender has sent five messages. Is one second. Yeah, he is the sender who sent five messages, and he is the another sender who sent five messages. And these are the receivers who received more messages, and this is the sender who received more messages. He is a receiver who received more messages, and I have implemented a graph based on date and temperature. On a particular date, what is the rise of temperature? If you see here, the temperature is increasing in some days and it is keep on decreasing. It is not constant, it is variating. But finally, it was in between of 20 to 30 only. It is not beyond that. And this is the graph based on speed of the date. What is the wind speed on particular day? This analysis is somewhat like that weather analysis, but this also may vary of results, right? Based on dishonest messages comes why based on good based on not good readings, right? Maybe based on the anomalies also the dishonest may become, and this is the temperature and count, means how many times a sender sent this particular temperature message. And thank you.